Hey, hi everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is maximum value of an ordered triplet part 1. Question number is 2873. Even in the question, it is easy, and yes, we have two solutions for this. First solution is O of n cube times complexity, and this solution is easy. But we are going to come up with a solution with O of n as a time and O of 1 as a space complexity. And honestly, this part is not easy. This you can consider as a medium level if you are trying to solve it using O of n time complexity and O of 1 space complexity. We are given an input, and the input is just one array of numbers. For example, 12, 6, 1, 2, 7. This is one of the input we are given, and for this the output is 77. How are we going to produce the output? We need to understand it using the task. The task is to find the maximum triplet which is possible using three indexes I, j and k. We need to find the triplet. Triplet means we need to use three numbers, and for three numbers we are going to use I, j and k indexes such that I should be less than j and j should be less than k. Means you need to choose three numbers out of this, any three numbers, such that you will have to assign the first number as I, second as j and third as k. Alright, you cannot use it as I as the first element, k as the second one, and j as the third one. Whatever three numbers you are using, the first two are going to be I and j, and the third is going to be your k. To get the value of a triplet, you need to use this particular formula, nums of I minus nums of j, and whatever is the output of this, you need to multiply this with nums of k. This is your formula to find the triplet, and you need to output the maximum triplet which is possible using three indexes. And again, you need to follow this rule that I should be less than j and j should be less than k. For example, you can use these three numbers as your triplet. Here 12 will be your I, 6 will be your j, and 1 will be your k. Well, I, j and k are indexes, so I will be 0, j will be 1 and k will be 2, and these are the numbers at those index. And now using this formula, 12 should be placed here, minus 6, and whatever is we are getting here, we need to multiply it using 1, for nums of k is 1. 12 minus 6 is 6 multiplied by 1, this is equal to 6. Now this is one of the valid triplet value when the value of I, j and k are 0, 1 and 2 respectively. And since the output is 77, we know that there is some other triplet we can create using this given array such that the output is 77. What can be that? Let me tell you. If you try to select this, this and this, these three elements, 12, 1 and 7. In this case, you will notice that 12 is at index number 0, 1 is at index number 2, and 7 is at index number 4, and 0 is less than 2 is less than 4. This condition is satisfied. We have chosen three indexes which are different, and if you put it into the formula 12 minus 1 multiplied by 7, then this is going to be 11 multiplied by 7 equal to 77. That's the maximum we can produce. Now there are two ways to solve this particular question which I have told you in the start. First one is the easy way, and this is going to be O of n cube time complexity. That is, we are going to run three loops, and the question is accepting this solution. So I will show you the solution, and the approach will be very simple. We are just going to run three loops. This is one of the good hint I can give you. If you run three loops, something like this. For example, if these are your numbers, your indexes are going to be 0, 1, 2, 3 and 4. You have three indexes to choose, I, j and k, and the condition is I should be less than j and j should be less than k. In this case, your starting point will be I at 0, j at 1 and k at 2. Means you start I at the initial value, j should be I plus 1 and k should be I plus 2, and then you will have to run your loop, and your first pair will be 0 and 1, and this k will go from 2 to 3 to 4. You will form three triplets, and you will calculate the value of this particular triplet, and whatever is the maximum you have got, that will be your maximum after processing I at 0. And again, you just need to increase the value of I and j. I will be at 1, k will be at 2, and k will be 3 and 4. You will form more triplets, 1 and 2, and using this number and using this number. So two more triplets will calculate the value, and whatever is the maximum you have got till so far, that will be your max. So after processing it using the three loops, you can simply return your result, and that will be your solution. This is one of the solution using three loops. The first loop is with I, the second loop is with j, and the third loop is with k. You will notice that I is starting at 0, j is starting at I plus 1, and k is starting at j plus 1. And every time we are storing the result as maximum of my current result value and applying this particular formula. And after coming out of the loop, I can directly return the result. If you submit this code, then also this will be accepted, but you will notice that the solution is not very efficient. See, it is accepted, but we are at the bottom or at the rightmost part of the time complexity part, right? we want to be at one of this place, right? So let us see a optimized approach to solve this particular question. And honestly, the optimized approach is not easy. You will have to apply some algorithm, think about some logic, and then you will come up with the solution. So if you solve it using O of n, this can be treated as a medium level problem. Now, what can be the approach to solve this problem using O of n and O of 1 times space complexity? So we are not going to use any extra space as well. Now, what can be the thought process? The first thing is you need to find the triplet. Now, triplet means you should have at least 3 numbers, and even in the input, if you will notice, the constraints are given something like this. The number of elements in the array will at least be 3, and all the elements will be positive. So we know that we need to process at least 3 elements to come up with at least one solution. Let us try to understand it using 3 elements, 12, 6 and 1. And let me create another input, let's say 12, 13 and 1. We will come to this one, but for now let us focus on this, which is the first 3 numbers in our input. Now you will have to think a very important thing here, and that is, if these are your numbers, what is the output? Well, the first thing is you just have one triplet which is valid. You can place your I here, j here and k here, such that I is less than j and j is less than k. In this case, when you apply this particular formula, 12 minus 6 is going to be 6. You multiply it with 1 and the output is 6. And that is the maximum you can get. That is correct if the input is 12, 6 and 1. But what is the observation when we have this as an input and this as the output? The observation is you need 3 numbers. That's the first observation, and we got 3 numbers. And the triplet formula is nums of I minus nums of j multiplied by nums of k. So here we have 1 and 2 factors which are getting multiplied. Now simple maths has to be applied here, that if you want to maximize this value, you need to find the maximum of these values which are possible. So the first one is difference, the second one is the multiplying factor, right? So what's the maximum difference you can produce using this particular data? Now don't say that the maximum difference is 6. The maximum difference is actually 11. You can say 12 minus 1. 12 minus 1 is 11. That's the maximum difference you can produce. This can be I and this can be j. But the problem is you don't have a k at this point. And that is why you are not going to use 12 minus 1. Instead of that, you will have to use 12 minus 6 to get the maximum of the difference and then multiply it with k. So here we found that if we want to create a triplet, the difference, the maximum difference has to be created using the elements which are before the last element or before your current element. For example, if the input is 12, 6 and 1, you cannot use 1 to produce your maximum difference. But if the input is 12, 6, 1, 2, here you cannot use 2 to produce your maximum difference, but you can use 1, right? You can use 6, you can use 12 as well, right? These 3 numbers can be combined in such a way that I is less than j and you produce this maximum difference. And then you will have to multiply it with your current number k and see if you can create the maximum value of your triplet. Now what about this case? In this particular case, since we again have 3 elements, we cannot use this to create our maximum difference. What we need to do is we need to use these 2 elements, and the maximum difference we can produce is minus 1, and we need to multiply it with the third number which is actually 1 here. So minus 1 into 1, this will be equal to minus 1, and the question says that if the output is negative, then you can consider 0 as your output. So in this case, the output is going to be 0 because there is one triplet which is possible, and that triplet is having value as negative. We can directly output 0. Now let us see the dry run of what formula I'm trying to apply. Get the solution as O of n and O of 1 time complexity. See, these are our numbers. Let us try to find out the result at each point. This is going to be our result. Ultimately, you will see it is 77. That is our actual output. But how we are getting this is very important. Your first number is 12. At this point, will you have a result? You will not have, because we have just saw one number and we need a triplet. But at this point, I know that my maximum number which I can get is 12. This is not the maximum difference. This is the maximum number I can get. And can I get a difference at this point? I cannot get a difference at this point. The reason is, to get a difference, I need at least 2 elements. Again, coming back to the formula, we need I and j to get the maximum difference, and I and j should be different such that j is more than I. I'm talking about indexes here, right? And then we are going to use the nums of k. What we can do, at this point, we just have one information that 12 is our maximum element after processing the first element. What about the second element? Second element is 6. Is it contributing to our result? No, it is not. But it is contributing to one thing, the difference. Because now we have processed 2 data, 12 and 6. We can put I here, we can put j here, minus their elements will be equal to 6. So after processing these 2 data, we have got 2 information. My current maximum value is 12, but my current difference is 6. My current maximum difference is 6. And the reason is, the current maximum value is 12. I have got a new number 6. So I can just say 12 minus 6 and that will be equal to 6. That is the difference. Earlier my difference was 0. And since my new difference is more than my earlier difference, this new difference is going to be the maximum difference for now. But imagine if your earlier difference was 10, then in this case, this will be 6. The current one will be 6, but this will not replace your maximum difference. It will still be 10. So we need to store the maximum difference here. Because if you see the formula again, in the formula you have two things. First one is the difference and second one is the multiplying factor. Both need to be maximum to maximize our result. Now let us try to process the third information, which is 1. At this point of time, you will notice that you can form a result. What is your current difference? 6. 6 is the maximum difference you have got after processing this data. And you have got another data. So I is here, j is here, right? This is I, this is j, and this can be your k. And in this case, after processing I and j, the difference is 6. What is the value of k? It is 1. 6 into 1 can be 6. And what is your current maximum result? It is 0. And since 6 is more than 0, this will be your new result. And after processing this information, you have a result as 6. You still have the maximum value of 12, but the difference is now 11. The reason is I can use I equal to 12, k as 1, right? And using this, I can form a maximum difference of 11. Well, I cannot get a result with this because I need another k, right? But at this point of time, this was our I, this was our j, and this is our k. This is storing our result. But to maximize our result, what we are doing is we are maximizing the difference. Okay. So although the current answer is this one, I, j, and k, with the value as 6 as the result, but to maximize this, what we are going to do is we are going to shift our j here after finding the result, not before finding the result. And now the difference is going to be 11. But if you try to find the difference before processing the result, then in this case, this will be your I, this will be your j, then you cannot use this one as your k as well. And that is why we are first trying to find the result and then we are trying to find the maximum difference. Now we are going to apply the same formula. The new number is 2. My current maximum difference is 11. 11 can be multiplied with 2, right? Because after processing this data, my maximum difference is 11, which is I and j. My new k is 2. Now this is my data triplet 22. My previous triplet was 6. I will replace this with my new triplet because that is more. This is 22. Maximum value will still be 12 after processing the first 4 data. And after processing the first 4 data, the difference is still 11 as the max. Then you can use the next element 7 as the new k. So use this 4 data. The 4 data will give you I and j. The I and j will not change because this is our difference 11. But the new k is 7. 11 into 2 was 22. Now 11 into 7 is 77. So since this is more, this is going to be our current maximum result. And since we are at the end of the loop, we can directly say, hey, 77 is our output. And that's it, guys. We just need to run a loop and maintain 3 variables: result, maximum, and the difference. And at the end, we will have the maximum result stored. Now let me take you back to the code editor and try to solve this using Python. So let me get rid of this code for now. Okay, this is our O of n cube code. We are going to optimize this. First of all, create a result variable that is going to store our result. Then create a maximum variable. This is going to store the maximum value we have got after processing each input. And then we are going to store the maximum difference we have got after processing each input. Now let us process each input in our array for n in nums. First of all, we are going to store the result. The result is going to be the maximum of my current result and n multiplied by difference. The current element, let me consider this element as my k, and whatever difference I had earlier, that will be used. So initially this will be 0. Then we are going to update our maximum value, and this will be equal to max of two things: the current maximum value and the new number which I have got. And after this, we just need to update the difference, and this will be equal to whatever difference we have for now, the maximum of the current difference we have for now, and the new difference which we can create using the current maximum and the current number. The first part is your existing difference and the second part is your current difference. Whatever is maximum, that will be your difference. So after processing this, the result variable is going to store the maximum value of a triplet you can create, and then finally you can return the result. So now you can just submit the code and you will find that this small piece of code is a pretty efficient solution for this particular problem. You can see the time complexity is good, the memory used is good, right? So I think that's it for this video, guys. We have solved this particular problem, and if you liked the explanation of this particular problem, then make sure that you hit that like button. And if you're not subscribed to my channel, then you can subscribe to the channel as well. And if you have any questions, then make sure you put it in the comment box and I will definitely reply to it. And I will see you guys in the next video. Thank you for watching this video, guys.